I'm Andrew, and I am a Security Operations Center analyst or a SOC analyst. And basically, what that means is I am in charge of defensive and proactive security across a bunch of different organizations. So I had a few people ask me what a denial of service attack is. So I put together a little presentation, and hopefully, this kind of gives you a better understanding of it. So, denial of service, what is it exactly? So, it's an attack that floods a machine or network with requests to disrupt business operations. Requests overwhelm endpoints, causing them to slow and sometimes crash, and causes disruptions in access for legitimate users. So, success usually relies on attackers having more available bandwidth than the target to kind of take it down or offline or slow it down to the point where it's not really viable anymore. So this attack violates availability in the CIA triad, which, if you are unfamiliar with the CIA triad, that's confidentiality, integrity, and availability. Availability deals with the kind of notion that all resources should be available to people who need access to them at any point that they need it or is required. Attack types. What kind of denial of service attacks can be carried out? So we have two main ones: buffer overflows and flood attacks. So buffer overflows are the most common. The attacker drives more traffic to a network address than the system is capable of handling. So this causes machines to consume all available memory storage regions that temporarily hold data, or buffers. So this occurs when volume of data exceeds available bandwidth, resulting in a slow performance or a crash. And this can deal with CPU, memory, disk space. So sub-attacks of buffer overflows. We have stack overflows, and this is going to be when the program tries using memory spaces in the call stack it has been allocated to, and this overrides buffer boundaries. So what it's able to kind of handle in a way. Unicode overflow is going to be created through Unicode. Unicode is inserted in expected ASCII output, and they both deal with encoding. So that kind of gets a little funky in places as well. Flood attacks are when systems receive too much traffic for a server to manage. So an example of this would be an ICMP flood or a Smurf or ping attack, and this exploits misconfigured network devices. Attackers can deploy spoofed packets to ping each device on targeted networks without waiting for a reply. And then we have a SYN flood. So this is when connection requests are sent to a server and they don't complete the three-way handshake. They essentially just stop at SYN. Kind of similar to
Hi, I'm Tom. Hi, I'm Tom. Hi, I'm Tom. Hi, I'm Tom. Huh? Hi, I'm Tom. 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 Hi, I'm Tom.
requests continue to flood the system until all open ports are saturated. So that bogs down all the network traffic and makes it pretty hard for people to access the content that they need. DDoS, or distributed denial of service attacks. So this is a little different. This is by far much more complicated. It is an orchestrated attack launched from multiple locations by several systems simultaneously. So this leverages multiple devices across a variety of geographies rather than a regular denial of service attack, which is typically from a single device. And they are typically considered more sophisticated and a larger threat to organizations. How does it work? So we have zombies. So zombies are going to be computers connected to the internet that have been compromised by a hacker, and this can be used to perform malicious tasks under the remote direction of the hacker. Zombie computers often coordinate together in a botnet controlled by the hacker and are used for activities such as spreading email spam and launching distributed denial of service attacks against web servers. So essentially, we're taking all of this CPU power, we're taking all of the power of every computer in the botnet, and we are pointing it at a single server to override it with requests or do something similar to get it to be so slow that it eventually crashes or it's just unusable. Down here, we have a definition of botnets and a kind of little picture displaying what a centralized client-server relationship looks like. So here we have a hacker, and then we have a bunch of command and control servers, and then we have bots. And essentially, with distributed denial of service, this is taking all the bots or the zombies, and it is pointing them at a specific resource to take it offline or slow it down until it is unusable. So identifying a denial of service attack. So there are three things that you can kind of look for: slow network performance, inability to access online resources, and interruption or loss in connectivity. Unfortunately, these three things are also tied to maintenance and other troubleshooting tasks that may be going on due to IT, but these are indicators. Mitigations. So what can we do to protect ourselves? We can establish consistent and comprehensive training. This video is an excellent way to start. Verify extortion attempts when they occur. Go and look into the thing, make sure that nothing bad is happening, make sure that it really is a denial of service attack so you can mitigate effectively. And you also want to conduct routine tabletop exercises and penetration testing for those cyber enthusiasts or people in organizations. We want to segregate backups to prevent enumeration. We want to encrypt our data. We want to ensure best security applications like really good antivirus and paying attention to security controls. We want to create communications plans so we know what to do when the attack happens, because unfortunately it most likely will happen at one point in time. We want to contact law enforcement. We want to report any indicators of compromise, anything that might relate to this attack, so that the law enforcement can do their best with the intelligence that they have. And last but not least, we want to update our computer. Security patches really do reduce the attack surface across the board, and they will greatly help you. That is pretty much it for our overview of denial of service. We'll cut over to a practical example. Now, I just wanted to mention, with great power comes great responsibility. I am not responsible for any actions that people may take from the content in this video. This is for educational purposes only. I just wanted to demonstrate what a denial of service attack could potentially look like, as there really isn't very many practical examples out there. So here I have a Windows 10 virtual machine. Basic configurations. Essentially, it's unaltered. Back in high school, I was taking an A+ certification prep course. We were learning about the command line, and we discovered that you could make batch files, which are very basic scripts. For example, if we wanted to open a command prompt with a batch script, what we would do is we would create a new text document, and we would open up the text document and we would type in start. Then we would save the file as, and we would save it as a script and go to all files and put a .bat extension. So if we say save, we now see we have an icon on the desktop with these little gears on them, and it's showing as a Windows batch file. So let's exit out of this. We can delete our text document, and let's double click this and see what happens. So we see we have a command prompt that pops up. Cool. So we really liked the idea that we could make a script like this and it would automatically do stuff. So we wanted to test our limitations. We were just starting out and we wanted to see what it could do. So let's right click and go to edit. So here's our notepad again. Let's see what happens when we type in 2 starts. And let's save that and run the file. We have 2 command prompts. Wonderful. That's really cool. So we wanted to see how many they could actually open. So if we go back to that file, we have 10 starts in this file. So let's save that and see what happens. So if we double click this, we have 10 starts that come up. If you've ever taken a programming class, or if you've ever experimented with scripting or anything like that, you understand that there needs to be a limitation on whatever you're programming. And that's because people can do some crazy stuff with them. So we have 10 command prompts that are opening. Okay, that's cool. We can open up 10 command prompts. But what if we Control A, copy, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's save that, and now we have 100 command prompts that are opening. Now, this is a little annoying because it delays you just a little bit. But let's go ahead and right-click on these command prompts, close all windows, and let's take those 100 and let's duplicate that, and let's put 1,000 of these in. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Cool. So file, save, and let's open it up. Okay, now we're getting into the realm of this is detracting me from my work. This is a nuisance. Why is it doing this? I am confused. That type of a thing. In all honesty, in this moment, we would simply try to do a Control-Alt-Delete, and hopefully that opens up the task manager. But we can see that it's now trying to do both at the same time, and so you're not really getting anywhere. And now we have preparing security options, task manager, and it's still trying to open it up amongst all of these command prompts. And so you can see kind of how effective denial of service can be. These are a bunch of command prompts that are being opened all at the same time, and the computer can't handle all of those requests all at once. So in this case, really all that we can do would be power off the machine. But they should finish in just a moment. There we are. So if we go down to the bottom, and there's our task manager, and we see all of this, we can right-click and close all windows. And hopefully that will close majority of the command prompts. So you can kind of see where I'm going with this. That's essentially what a denial of service attack is. So when my friends and I were developing this, I wanted to be able to pull pranks on people. And we didn't realize it, but at that time we were actually setting up malware. So this is kind of how it went. I had a dear friend of mine that was in a different period and on the same computer. Now, this was back in the day, and so everybody used literally the same account. There was no separate account, it was actually named student. So it didn't matter what period you were in, you just signed in under student, and they made it as easy as they possibly could. So we shared desktops quite often. It was funny. We had background wars and all kinds of other stuff. While we were learning about the command line and while we were learning about batch scripting, we were venturing into other realms of possibility. Case in point, we have this right here. Now, this looks like a very, very simple few commands that will just, do a couple of, basic programmatic things. And that's exactly right, but put in the sequence, it opens up an endless loop. Now, what happens with this whole thing? So we have :1. So that is a point that we can reference back to later on in the script. Now we have start. We already know what that does. Start is there to open a command prompt. Now in echo is literally writing a line of text to the command prompt. So it's going to start, launch a command prompt, then write a line of text to that command prompt. Then it's going to go to 1. Now, where does it go? It goes to 1. So this is 1 right here, and then at 1, it then launches a command prompt, and then it echoes this text. Then it goes down to go to number 1, and you guessed it, it goes back up to number 1. Now, this never ends because there's nothing really to stop it from ending. So if we copy this over into the virtual machine in the script file, so right click, edit, and then we control A and V, and here we have our script. So we file, save. All right. It's essentially like writing start over and over and over and over and over again, along with this silly line of text that you can pretty much make whatever you want within these quotes. We have this file. Now, I had a friend that used the same computer that I wanted to get to crash the system. So I said, how am I going to get dear Tony to click on this file? Nobody's going to go in and just click on a random file. That's silly. So how would I go about doing this? How would we get someone to click on this? And so that's when you can kind of get a little crafty. So I decided that I was going to disguise this file as something that he clicked quite often. So I moved this file off of the desktop so that nobody could see what it was. So let's go over into Documents and right-click and New and Folder. And we will call this Taxes. And let's paste that file in here. Now, we can name this file whatever we want. Let's not name it script. Let's name this totally not a sus file. Cool. So we have totally not a sus file, which contains that script, that loop. So let's right click on that and let's go down to create shortcut. So now we have a shortcut to the file. So let's drag that onto the desktop. Now, I took keyboarding before and I knew that we had to access the internet. And so I went over to the file and I renamed it to Microsoft Edge. But if you look at this, it's still a little questionable because this has years on it. It usually doesn't look like that. So let's right click on it and go down to properties. And here we have a change icon button. So if we want the icon of Edge, we're going to need to trace the file location based on another shortcut. So if we go down here to start and we look for Microsoft Edge and we right click and we go down to more and then open file location. Now we have a shortcut that we can use. So right click on Microsoft Edge, go down to properties, and then change icon. And here we have the location of the icon itself. So if we control A and copy and go over to the file on the desktop, right click, properties, and then into change icon and OK. And we paste that file path from Microsoft Edge here and enter. Here we have the Microsoft Edge icon. Okay. Apply and OK. Now, I don't know about you, but I'm going to click on this. I mean, it's if you hover over it, it says location, totally not a sus file. And it tells you exactly where the actual icon is. Maybe you'll actually lose that. You can change that, obviously. But coming in, especially if it's 7:30 a.m., like it happened to be when he clicked on it, then, you know, you're not going to pay attention to the little things like that, usually. In any case, so before we run this, I am going to do one last thing. Take a snapshot so that we can simply revert back to it instead of waiting for the computer to decide it's done crashing. So let's go over into the VirtualBox Manager and let's go over to the hamburger menu on the right, go down to snapshots and then take, and we're going to name this fire in the hole. And OK. Taking online snapshot. Now, this is going to take up more space if you do it while the virtual machine is on. It is an active or a live snapshot. If you want to save space, you can totally power it down, take a snapshot, and then power it back up. So now we have a snapshot, and we can totally just revert back to it if anything goes wrong, which it definitely will in a matter of seconds. Came in at 7:30 a.m. the following day to catch up on some work that he was missing. He wanted to get it done as quickly as possible. He got to the computer lab and he opened up the browser. And then all of this happened. And he stopped, and not having much technical ability, he freaked out. Now, luckily, he was a friend of mine, and he knew that I sat at the same computer that he did. And he was like, "What did you do to the computer?" And I said, "Oh, that's funny." So I ran back up with him. I looked at the computer. The teacher was there, very, very furious. And I said, "Oh, all you have to do is," and I pressed the power button, or in this case, the X, power off machine. Now, in this case, we're going to restore current snapshot fire in the hole. And that will put us back right before we actually executed this monstrosity. And we say, OK. And now if we boot the virtual machine back up, right before we executed that piece of malware. In the last segment, we went over denial of service. We crashed the computer with a bunch of command prompts, and that was a pretty basic buffer overflow attack. In this case, I wanted to show you kind of what a distributed denial of service attack might look like. Here on the Windows 10 machine, I have done just a few things to it. I have installed IIS, or Internet Information Services, and that basically puts a web server up on the virtual machine. So we actually do have a web server running, hosting a web page. I also allowed a bunch of ports through the firewall so that we can kind of see what we're doing. And I also installed Wireshark. So let's go ahead and open that up. And what this is going to do is essentially analyze network traffic on the device. So we can open this Ethernet option here, and it should start to populate with all of the network traffic that's going through the machine live. So we should see that in just a moment, but let's also open up Task Manager. And we see the network is at 0%. Performance, we are at a very low level. We can see that the upward bounds is 100 kbps. So really not that much going on over here either. We should be able to see anything that is happening on the network side of things through Wireshark here. So we see a bunch of different IPs and actions happening in the background, and this is just while we're navigating through the virtual machine. So if we wanted to figure out what IP is hosting the web server, we can go ahead and use nmap. So we're going to say sudo nmap -a for everything, -vvv for very verbose. We're going to look at the entire subnet that we're using. So that's 10.0.2.1 and over 24. I got that number from the network that I configured. So if we go back over to VirtualBox Manager and we open up the network tab, we see our AD network and we see the prefix here. And this is what we're scanning. So it's going to be 10.0.2.1 all the way through 10.0.2.255. So if we go over to our Kali box and open up our Wireshark, we should be able to see what's going on after we run this. So if we hit enter and type in our password, all of a sudden we start to see all of this traffic start to pop up. And we can see that it's coming from 10.0.2.15, which is actually the IP address of this Kali box. Now, if we scroll out, we can see that there are a bunch of hosts that are down, but we also see a couple of hosts that are up. And so for 80 on 10, 02, 16, 135, 445. So I think it's safe to say that this is going to be our device, this 10.0.2.16. And we can see right here that that is the other IP that we are kind of looking at. We can stop that, and we see the traffic slow down quite a bit. We can see the Nmap scripting engine actually trying to pull information and attempt some really basic scripting stuff on the offensive side of things. So we kind of know where we're going. Let's try and see if we can contact the web server. So we see that majority of the traffic is going through 10.0.2.15, which is going to be our Kali box. We type in ifconfig, we see our IP address is 10.0.2.15. Now let's see if we can contact the web server 10, 02, and 16. And now we're seeing ICMP ping requests coming from the Kali box. And we see a response over here. So we know that they're both talking to each other. So if we hit Control and C, we see the traffic start to slow down quite a bit. So one example of denial of service over the network, when you have a whole bunch of computers that are pinging the machine all at the same time. So if we say ping and 10.0.2.16, we see that we're having a little bit of traffic, right? But if we were to split that window and send another one, ping 10.0.2 and 16, we see that it gets a little faster. And we can continue to do this, and it'll get faster every time. Now, this may not seem like a lot of traffic, and this definitely won't take down the machine in any regard. Imagine if you had a botnet behind you. This would be kind of bad. If we go over to our traffic manager, we see our Ethernet has spiked just a little bit. And if we go over to our processes, there is like literally no impact on the network whatsoever. Okay, so let's go ahead and let's close this. All right, so we know it's a web server. Let's go ahead and go to it so that we can make sure that we're actually seeing a web page. So if we throw in 10.0.2.16, we can see that we're getting a bunch of traffic from 10.0.2.15, and we have this little picture that if you click on it, it takes you to Google. That's pretty much all the functionality I have in it because I just wanted a placeholder, something to attack, but that's essentially what it is. So if we want to simulate a distributed denial of service attack, we are going to use a tool called hping3. What it does is it sends and crafts packets for you. It has a lot of granularity, so you can do quite a bit with it. So sudo hping3 -c for count. We're going to send 1,000 packets. -d for data in each packet, that's 100. -s, since we're doing asyn flood. We have --rand -source, and then we have --flood. And then we have the IP address that we're attacking, 10.0.2.16. Okay, cool. If we go over here, we can see that there really isn't much going on. Now, this rand source argument is going to make it look like it's coming from a whole bunch of different IPs. So let's actually take that out for just the first demonstration. And let's test this out here. So if we hit enter and put in our password, all of a sudden we start to see all of these TCP requests coming in. And we can see that they're not being finished whatsoever. It's actually kind of hard to select a packet while all of this is happening. It's bogging down the workstation. And so, like, this is really the heart of everything. We see that there's just traffic coming in. If we stop this, we're going to need to give it a second to catch up. But if we go over to our network tab, we can see that traffic went all the way up, way past 200 Mbps. We can see it dove really quickly right after we turned it off. And we can also see that it's using a substantial amount of the disk, and the memory is also kind of high up there with Wireshark not being able to catch up. If we go back over to our PCAP, we can actually hit the stop button to get it to stop. And we can see it's still going, so just give it a moment. He actually got Wireshark to crash. Let's go ahead and open it up again, Wireshark. And then we'll hit Ethernet. Okay, so let's go ahead and do the exact same thing, only this time we're going to put in this --rand -source, and that should make it look like the activity is coming from a bunch of different IPs. So it'll look like a distributed denial of service attack, but remember, we don't have a botnet behind us, so it's really just coming from one computer, but it's the IP addresses that will kind of show you what I'm talking about. So if we hit enter, now we see all of these random IP addresses that are hitting 10.0.2.16. Now there is no way to tell just from looking at this that this is 10.0.2.15. It's made to look like it's coming from pretty much everywhere else. So let's go ahead and cancel this so that we don't crash Wireshark again. And that is pretty much it. So again, much more deadly if you have a botnet behind you. This should give you a pretty good idea of what a distributed denial of service attack might look like. But that's pretty much it. I really hope that you found this video enlightening. Thank you so much for watching, and until next time, see ya.